vision of, first we will revise the concept. When the limit is set to exist, if a function which approaches from the right hand side to a constant, if it is equal to a function which is approaches from the left hand side, if both of these are equal, then we can say that limit of the function at x is equal to a exists. Limit of the function at x is equal to a exists. Now, there is few theorems on limit. Limit x tends to a, x raised to power n minus a raised to power n upon x minus a. This is equal to n a n minus 1. This is the second result. It is the first result. Now the third result is limit x tends to 0, sin x upon x, it is always equal to 1. Fourth result, limit x tends to 0, cos x, this is always is equal to 1. Fifth result, limit x tends to 0, tan x upon x, this is always is equal to 1. So there are 5 main results which we will use again and again in calculating the limits. The sixth is we have to take care of numerator. If the limit is of the form, suppose limit x tends to a fx upon gx. So you have to take care of this thing that the function which is in denominator will not be 0. If this function will be 0, what will happen? The total function move towards undefined. So we have to make this gx free from 0. There are various ways by which we can make gx free from 0. Number 1, by simplification. Number 2, with the help of calculation, with identities, with the help of rationalization, or by using trigonometric formulas. We can make gx free from 0 by all these means. Once it will be free from 0, then you will substitute the value of the limit, value of the constant in the limit in the function, then you can get the answer. So these 6 ways broadly are there. For example, is saying limit x tends to 3, evaluate x 481 over 2x square minus 5x minus 3. This is the question number 1. Now see, what we will see first. Substitute x is equal to 3 in the denominator. 2 is to 3 square minus 5 is to 3 minus 3. This is 3 is to 3, 9, 18 minus 15 minus 3. So that means it will be 0. So that means my denominator becomes undefined. So first I have to solve the denominator. Now, there is only one way to solve it. Do the factors of the denominator, then do the factors of numerator, do the simplification, then substitute the value of x in the function to get your answer. Now, my denominator is 2x square minus 5x minus 3. So this is minus 6. So can I write here minus 6x plus x minus 3. So take 2x outside. This is x minus 3 plus 1. This is x minus 3. So this is 2x plus 1 is 2x minus 3. So limit. So this is x square minus 9 is to x square plus 9 upon 2x plus 1 is to x minus 3. Now this is limit x tends to 3, x plus 3 is 2x minus 3. This x square plus 9 becomes as it is, divided by 2x plus 1 is to x minus 3. So this x minus 3 is cancelled in numerator and denominator because this is the problem. This was the problem with us. Okay, so it is now removed. Now my function becomes free from 0. So this is x plus 3 because all the terms have a positive sign. So that means there is no scope of getting 0 in the function. So substitute the value of x here. So this is 3 plus 3 is to 9 plus 9 upon 2 is to 3 plus 1, which implies this is 6 is to 18 upon 7. So this is the final answer of this function. Let me know once you will note it down. Then I'll move to next question. Question number 2. This is another type. I will try to do few type. I will try to cover few types here. B minus ax here. X is less than 0, x equal to 1, x greater than 1. So when x is less than 1, we will use the function a plus bx. When x is equal to 1, we will use 4. When x greater than 1, this is b minus ax. And he has given us that limit x tends to 1, f of x, this is equal to f of 1. I want to find out the value of a. So this is limit x tends to 1. So limit x tends to 1, that means positive limit and negative limit both exist. So I will just cover only one limit, that means maybe positive or negative, we will go with the positive. So limit x tends to 1 positive. 1 positive means b minus ax, because he has given me that when x is greater than 1, I will use b minus ax. So which is equal to f of 1. F of 1 means when x is equal to 1, the value is 4. So I'm going to write it here as a 4. So put x is equal to 1 plus h. Limit h tends to 0. Substitute the value of x. This is 1 plus h equal to 4. Limit h tends to 0. b minus a minus ah equal to 4. Now substitute the value of h. So this is b minus a is equal to 4. Take it number 1. Now I will move to the positive limit to get the second equation. So limit x tends to 1 negative. When x is less than 1, this is a plus bx. So I'm going to write it here as a plus bx, which is equal to f of 1, that is equal to 4. So put x is equal to 1 minus h. I hope you people have noted. So I'm going to clean it.
Yes, sir.
So limit h tends to 0, a plus b is to 1 minus h, which is equal to 4. So limit h tends to 0, a plus b minus bh equal to 4. That is a plus b equal to 4. This is the second equation. So we will solve from 1 and 2. this is my b plus a equal to 4. This is my b minus a equal to 4. If I will add, this is 2b equal to 0. So my b equal to 0. Substitute the value of b in number 2. So my a is equal to 4. So this is the answer. So a is equal to 4. So this is the second type.
Sir, question.
Anji?
Sir, when we put the value of x as 1 minus h or 1 plus h, then why we extend h to 0 only?
मैं बताता हूँ अभी, ये देखिए, ये देखिए। सो आपके पास क्या है, आपके पास है, मान लो लिमिट x टेंड्स टू 1 पॉजिटिव b minus ax equal to 4. So I have substituted put x is equal to 1 plus h. अब देखिए, if I will approach x towards 0, that means कि x 0 की तरफ जा रहा है but 0 के बराबर नहीं है. So when this term will be near to 0, what will be x? X will go toward 1 positive. तो यही तो लिखा मैंने, ये देखिए, x is going towards 1 positive. ये देखिए. So that is the reason I am writing h tends to 0, because my original value of x is towards 1 positive. So when I will approach h towards 0, x automatically will approach towards 1 positive.
Okay.
Now, third type, limit x tends to 1, x raised to power 1 by 3 minus 1 upon x raised to power 1 by 6 minus 1. This is the application of theorem of limits. That means limit x tends to a, x raised to power n minus a raised to power n upon x minus a is equal to n a n minus 1. So limit x tends to 1, x raised to power 1 by 3 minus 1 upon x minus 1 divided by x raised to power 1 by 6 minus 1 upon x minus 1. So I have divided the denominator of both the expressions by x minus 1 so that I can apply this theorem of limits in the function, in the given function. So which implies limit x tends to 1, x raised to power 1 by 3 minus 1 raised to power 1 by 3 upon x minus 1 divided by limit x tends to 1, x raised to power 1 by 3 minus 1 raised to power 1 by 3 upon x minus 1. So my this value, this is 1 by 3 a n minus 1. So that means n minus 1, this is 1 by 3 minus 1 minus 2 by 3. Whatever be the value of 1, it will be 1. So here, this is 1 by 6. So 1 by 6, 1 minus 5 by 6. So which implies it will be 1 by 3 upon 1 by 6, which implies 1 by 3 is to 6 by 1. So that means which implies 2 is the answer of this question. So this is the third type. I'm trying to cover every type with you. So see it. Once you will note it down, let me know, and I'll clear the screen and we'll move to the fourth type. That means the limits of the trigonometric functions.
Done, sir.
Next is question number 4. That means fourth type. Limit x tends to 0, cosecant 2x, cot 2x upon x. Limit x tends to 0. Now, cosecant can be written as 1 over sine 2x minus, this is cos 2x upon sine 2x upon x. Limit x tends to 0, 1 minus cos 2x upon x is 2 sine 2x. Now first I will try to neutralize this sine 2x. Limit x tends to 0, 1 minus cos 2x over x is 2 sine 2x upon 2x multiplied by 2x. Because I have a theorem with me, limit x tends to 0, sine x over x is equal to 1. So my sine x over x, because here the angle is 2x and in the denominator also there is 2x, so this is equal to 1. So now my net function becomes 1 minus cos 2x upon 2x square. So which implies this is limit x tends to 0, 1 minus cos 2x, this is 2 cos square x upon 2x square. So 2 goes with this. So limit x tends to 0. So this is sine, not cos. Because 1 minus cos 2x, this is 2 sine square x. So this is equal to sine x upon x whole square, which implies this is 1 whole square, which is equal to 1. So in this way, you can apply. Now, one more question. Question number 5. Here you have to apply the rationalization concept. So which implies limit x tends to 0, 1 plus x minus 1 minus x upon x. This is 1 plus x plus 1 minus x upon 1 plus x plus 1 minus x, which implies limit x tends to 0, a minus b, a plus b. This is 1 plus x minus 1 minus x upon x is to 1 plus x plus 1 minus x, which implies limit x tends to 0, 1 plus x minus 1 plus x upon x is to 1 plus x plus 1 minus x. So 1 goes, this is limit x tends to 0, 2x upon x is to so which implies this is 2 upon 1 plus 0, which is 2 upon 1 plus 1, which is 2 upon 2, which is equal to 1. This is the answer. So here you have to apply the rationalization. Why? Because when you will substitute the value of x here, the denominator becomes 0 and the function becomes undefined. So we have to remove this 0 from the function. That is the reason I did rationalization and solve. Now, there are two more theorems. The results I am going to write. One is limit x tends to 0, e raised per x minus 1 upon x, this is 1. Number 2, limit x tends to 0, a raised per x minus 1 upon x, this is again is equal to log a. So these two results, for example, how the question can come here, you limit x tends to 0, e raised to power 5x minus 1 upon x. इसको solve करना है. अब देखिए, the theorem is e raised per x over x. So here is e raised per 5x over x. So what I will do, I will multiply and divide by 5. So limit either x tends to 0 or 5x tends to 0, doesn't matter. So e raised per 5x upon minus 1 over 5x multiply by 5. So this becomes 1. Multiply by 5, this is equal to 5. This is the answer. Last question. So try to revise within 2 hours, and then we will have a test in the next period. Although I have done the limits and limits chapter very thoroughly in the class. Limit x tends to 0, 1 plus 2x under root minus 1 minus 2x under root upon sin x. So again, because it is the term which contains roots, so you have to do the rationalization, because if I will substitute x as a here, sin 0 is equal to 0, my denominator becomes undefined. So ultimately my function will be 1 plus 2x minus 1 minus 2x upon sin x is 2. 1 plus 2x plus 1 minus 2x upon 1 plus 2x, then 1 minus 2x. Limit x tends to 0. So 1 plus 2x minus 1 plus 2x upon sin x is to 1 plus 2x plus 1 minus 2x. So 1 goes, so 2x plus 2x, this is 4x upon sin x, 1 plus 2x plus 1 minus 2x. So this sin x over x, this will become 1 because x tends to 0. So only 4 is here over 1 plus 0 under root plus 1 minus 0 under root. So this is 4 over 2. It will become, this is the answer. So एक बार एनसीईआरटी के सारे एक बार रिवाइज करना बेटा, देन सी यू. ओके, थैंक यू. इसको नोट कर लो. इफ यू हैव एनी डाउट यू कैन डिस्कस.
No doubt, sir. Noted, sir.
Okay, okay. Thank you, beta. Thank you.
Thank you, sir. Have a nice day, sir.
Thank you, sir.
Okay, beta. Take care.